So an analyst has been contracted to forecast the number of tourist arrivals in Australia for airline scheduling and booking purposes. The quarterly data for tourist arrivals in Australia from 2004 to 2007 is given below here. And these numbers are in thousands, so you need to multiply each number here by 1,000 to get the total number of people. So part A is asking us to use this information to find the adjusted seasonal indices for the tourist arrival data and interpret these for the June and December quarters. We're then asked to find how many tourists should be expected for the March quarter of 2008. So we're going to start on part A, which is asking us for these adjusted seasonal indices. So in order to do this, what we need is Y, all right, which is the actual values of our dependent variable. And we actually have these. That's pretty easy. That's all the data here. Remembering our dependent variable is the thing we're trying to predict. So that's tourist arrivals. But the other thing that we're going to need to calculate our adjusted seasonal indices is Y with the little hat on. And this is like the predicted amount based on a theoretical equation. And that comes from performing a regression model on our data. So that's going to be our first step, is getting this out. And then we should be able to combine these in order to get our seasonal indices. So I'm going to go over to Excel where my data is. So here we go. So what I'm going to try and get out is a couple of columns. So my first column, I'm going to call it the time period, okay? And we're going to number these from 1 up until however many time periods we actually have. We're then going to have the number of arrivals, and this is like our Y value, all right, the actual values. The next thing we're going to get is like our prediction, all right? Arrivals, I can't spell, arrivals. And this is going to be like Y with the little hat on. So I'm going to just put dash hat here because I don't know how to get a little Y hat on the top of it. All right, so once we've got all of this, we should be able to calculate our seasonal indices. All right, so time period. What we're going to do is start at, 1 and count all the way up to as many as we need. So I think looking at this, we've got 4 quarters and 4 years. So that means we have data from 16 time periods, 4 times 4. All right, the next thing is arrivals. So we want to have these in chronological order, starting from the first time period, which is this one here, all the way up. So it goes across and then we start the next year. All right, so this is just processing the data so that Excel is going to be able to analyze it for us. Cool. All right, so this last one here, this comes from the regression prediction model. So how we get that is we need to go into data and then data analysis and pick out the regression option. So this input Y range, this is our dependent variable. So we are trying to predict the arrivals. And the input X range, that's our independent variable, so the thing we control, and that is going to be the time periods. Okay, and this is why we've labeled them 1 to 16, because it needs to be numerical data in order to perform a regression on it. All right, so I'm going to tick labels because we had titles on our 2 different columns. And we need to tell Excel where to output this information. So let's put it out here. And I just went over my Y range. All right, let's put it there. So if we hit OK, it spits out our output. So what we're interested in is predicting this Y hat. So the equation is going to be equal to whatever the coefficient was at the intercept, which we'll call B0, plus the coefficient that we have for our independent variable, which is time period, multiplied by that independent variable, which I'll call x1 for the purpose of this. So that means that our equation is essentially going to be whatever we're predicting, which is the arrivals, is equal to the intercept, which we can see is this rounded about 6,011, plus the coefficient, which is 102.7 approximately for the time period, multiplied by what the time period actually is. I'll put TP for time period. So this is what we need to program over here as our arrivals. So equals, I'll use this one here as our intercept, plus we need to multiply by this coefficient, and the time period that is for this part is 1. Okay, so if we hit enter here, this is like the theoretical prediction of arrivals at this point in time. Now, I can click and drag this down, but it's not going to work out properly because it's going to change the reference cells that we're using. So in order to fix that, what we can do is go back into our formula, and if there is ones that don't move, so these never change, we're always going to be using 6011 and 102. What we can do is if you hit F4, I have to turn function off. Hit F4 here, it ends up putting little dollar signs in. So you can put these in manually if you want, but F4 is kind of the shortcut. So I want to do it for both of these so that it kind of fixes the reference. So then what happens is when I drag down now, it's going to keep referencing these two cells, but it will have dragged the one that we wanted. So that means I can now put this all the way down to the bottom, and these are all our theoretical arrivals. Alright, so the next step is to start looking at the seasonal indices, which we know are related to the y and the y hat values. So I might just jump over to the PowerPoint and write out the equations that we're going to apply. So the seasonal index for any one season, which I'll mark in here, is just the average of y divided by y hat for that season. And then in order to perform the adjustment, so the adjusted seasonal index for a given season here is equal to whatever we got from that previous line, not average, season. Okay, so this value here multiplied by the number of seasons and then divided by the sum, okay, of all of those SI values for every single season. So let's start by working on this first line where we need to get out that seasonal index for each specific season. So jumping back to my Excel. So what I might do in this column is find that ratio, so the y divided by y hat. So it's just going to be equal to these columns divided by each other. And what I should be able to do is drag down this formula, and that should update the references correctly. So it's always just dividing these columns against each other. So now what I need to do is kind of separate it back into the March, June and September quarters. So let me just copy this back down here. All right, and we'll just divide it back into the right column, I guess. So the first period was March, and the second one was June, and so on. June, September, and December. A little bit tedious, but again, just to make it easier for us to visualize this. All right, 2 left. This one, sorry. Alright, so now we should be able to find what the average is. So I'll do that down here. So equals, the function name is average, and we just highlight these. Should then be able to drag across. So this is the seasonal average for March, this is the one for June, this is the one for September, and this is the one for December. Okay, so that was the first step. The next thing that we wanted though was to find the adjusted seasonal average. Okay, so adjusted. And there was an equation for this. So it was you take whatever you got here for the seasonal average, and then you multiply it by the number of seasons that you have. So in our case, we've got the 4. And then what we want to divide by is the total of those averages across all of them. So if we then hit enter, this is our new adjusted seasonal average for March. So I need to apply this to the others. Again, I might go back and just This one here needs to make sure that it remains a fixed reference if I'm going to drag it. So pulling it across, what we should see is that the blue one is referencing the cell above, and then these are our sum that doesn't change. Cool. So these are our adjusted averages. If you want for a final answer, it's probably worth rounding them. So let's say around to 2 decimal places. So jumping across to our PowerPoint, what we were asked is to interpret the values for the June and December quarters. So looking here, the June one we can see is this 0.95, and December we've got 1.02. So let's do an interpretation. I'll start with June. So how I would interpret this is we've got 0.95. So we could say that that means that our arrivals in June are 5% below the trend, okay, because we're less than 1. So if we then interpret December, I would say that the arrivals in December are expected to be, we've got 2% here, above the trend. So yeah, that there would be my interpretation. Alright, so our last little bit here is to figure out how many tourists should we expect in the March quarter of 2008. So for this, what we need to remember is we've got our equation going, which is of the form y of t is equal to t of t multiplied by our seasonal component s of t. At the moment, we're kind of assuming that the cyclical and random component can be neglected. So that means all we need to figure out is what the trend component is for our time period here, and then what the seasonal component is for this, again, time period here. Alright, so jumping back to Excel, we were asked to look at March of 2008. So that's going to be like the time point that then follows all of this data we've got. So in our list here, it would be time point 17. So it's actually automatically calculated it for us. So y hat here, this is like our trend component, okay? So the t for time point 17 is equal to this 7,757. So the other thing that we needed was the seasonal component for our time point 17. And since this is a March quarter, okay, fitting in here, we should be able to scroll down and use our adjusted seasonal index for the March quarter. So that would be this one. Oh, let's highlight a different color. This one here of 0.99. So I can pop that in. So that means the predicted number of arrivals, which I'll call Y, for our time period 17, or March of 2008, it was equal to these two multiplied together. So that means that we are expecting 7,680.222, all right? Or remember that this was in thousands. So, oops, sorry. So I should times this by 1,000. So this is how many tourist arrivals we're expecting in that quarter. So that would be my final answer to that part of the question. So that's all there is for this video, and see you in a different one.